area of the shape below each square on the grid is a side length of 1 unit. So what this means is we could break this up into smaller rectangles like these. And this one's a 3 by 4 rectangle, so it has an area of 12 square units. Same with this one, so this one's 12 square units. This one's a 4 by 4, so it's a 16 square units. So this is going to be important just for this part of the lesson. Unless we decide that you guys like it, then we can use this method here in a moment.
Why is it square?
Square units because we're looking at the squares inside the shape. Or another way to think about it is that it's two-dimensional. So it's not just units, but it's units times units, units squared. Yes? Yep, then we would add these together. So yeah, we got 12, 12, and 16, which combine to give us 40 square units. So this unit has a lot to do with the Pythagorean Theorem. This particular lesson, we're looking at the proof of it, specifically the windmill proof of it. In numbers 2 and 3, a right angle triangle is shown in gray. The shorter sides of a right triangle are referred to as legs. The longer side of the right triangle, the side opposite the right angle, is called the hypotenuse. So let's look at a diagram of these. So if these two side lengths made up this right angle, they would be considered legs. Yes, the legs. All right. So the other piece that I was talking about is the side that's opposite the 90-degree angle. It's kind of like it points at it, this side. This is what we call the hypotenuse. All right, here's the nice thing about the way this works. Is if you have a right triangle, because the Pythagorean theorem is really an if-then statement. If you have a right triangle, then, and this will be important later, the if-then statement. Then if you took the two legs, so if I took this leg and I took this other leg, let's say that, for example, that I squared these and then added them. Then the sum of the squares of the legs would give me the hypotenuse. And that would be squared as well. So the two legs squared added together, if we take the hypotenuse squared, we would get the exact same value. But again, this is only if you have a right triangle. Yeah, so we're going to demonstrate this here in the next example. It's not that the lengths added together or squared, the legs added together would give us the hypotenuse, is that if we square them. So that means that I'm going to change these into squares, and that's this next part. Squares have been drawn adjacent to the sides of the right triangles. Find the area of each of the squares. Assuming each square on the grid has a side length of 1 unit, write the areas inside each of the squares. Here we go. So on a this example, we can see that we have a leg right here, and this side length also is a leg because it gives us this right angle up in here. Now, what are the lengths of these, by the way? This one's 2, and this one's 2 as well, right? Now, if I square those, I have the area of this new square right here. Both of them. So the area of this square would be 4, and you could count the squares. And this area right here would also be 4. Now what this means is that this other square right here is going to take the other two and add them together, 4 plus 4. And yes, the area of this one is 8. 8 units squared if you want. But we're not really so concerned about the area as much as the side length of this square. And this is where the square root stuff comes in handy. What's the side length of that square in gray right here? Well, how do we find it? If the area is 8 and we want the side length of close, you guys think divide? Since it's a square, we're going to square root that action. So the actual side length is the square root of 8. But here's the other thing with the square root of 8 is if you write that, you can get most of the credit, but you can't get full credit. Here is a Huan, and some of you guys have been retaking the standards on these. is if we split this up, we got 2 and 4, and then 2 and 2, which means it's really the square root of 2 times 2 times 2. And there's a pair of 2's, which is going to come out of the square root, and we got this other square root 2. So it's really not the square root of 8. It would be 2 times the square root of 2. That would be the side length of this is specifically a hypotenuse. Alright, so on this one, again, the idea for us is to be able to find the length of the hypotenuse. So we can look at this side length, which is 3, and that's a leg. And this side length is 2, which is also a leg. So the area of this square is 9. And the area of this square is 4. So the area of these would be the 9 plus 4, 13. Which means the side length of the hypotenuse is the square root of 13. What do you notice about the relationship between the areas of the squares formed adjacent to the legs of a right triangle? Well, what this means is that if you took the two legs, this should sound familiar by the way, and let's say that we squared these and then added them, as it turns out, it would give us the hypotenuse squared. Now, this is a little abnormal to write this out all the time because hypotenuse is kind of a long word. So, as it turns out, they began to use letters. They said the legs are A and B, and if we square those and add them, then we get the hypotenuse, which is C, and we square at these. So, in the future, when you see this A squared plus B squared equals C squared, C is the hypotenuse. We don't exchange A for the hypotenuse or B. C is always the hypotenuse. This A part right here is just asking for the same equation. So that is our equation. Now, we don't have to use the equation. So let's look at the directions here. In each of the problems below, a right triangle is shown in gray. The squares along each of the three sides of the triangle have been drawn. The area of the two squares is given. Determine the area of the third square, then write the answer in the square. Also find the side length of each square. Write the side lengths below each picture. So in this case, now it's giving us the area, not the side lengths, but these both are legs. So this one, we could just count it and say it's 3. You could square root 9. This length is 2. So this is the hypotenuse right here. And if I wanted the area, I would just do 4 plus 9er, which is 13. So yes, it is the same, but the side length is the square root of 13. Alright, so on this one, again, we're looking at these two legs. If the area is 36, then the side length would have to be 6. Right account, the area is 1, so the side length is also 1. So the area of this big one is still for the side length of the hypotenuse. And that would be 36 plus 1, which would be 37. So that's the area. So the side length itself would be the square root of 37. Alright, on this one, the one that we're trying to find on this, notice it's one of the sides that actually makes up the right angle, so it's actually a leg value, which means that the area of this leg added to this area 4 needs to equal 8, right? So this one, yeah, it would have to be 4. 4 plus 4 is 8. I hope so, but that's why it works. Now this length is 2, and this length is 2. So if that's 8, the length of the hypotenuse is the square root of 8, but we've already simplified that before. It was actually 2 times the square root of 2. All right, whatever. All right, this one, this is the area of the hypotenuse square. Right there, right?
Yeah.
This is a leg, and it has an area of 4. So it has to have a side length of 2. This is the other leg, but we don't know its value yet. Now, the area of this square, whatever it is, if we add it to the other leg area, it has to be 29. So when we solve for that area, we're just going to take 29er, subtract 4, and the area of this one is 25.
Oh, well.
That means that the side length itself is just 5. And we could find the hypotenuse by just square rooting the area, square root of 29. And now we have all of the values that we need for this.